In this video, we are going to look specifically at Venn diagrams and how to do some operations with sets. So first and foremost, let's go ahead and start with some information about Venn diagrams. So a Venn diagram is a very visual way to represent sets of information. It's a very good way to be able to see what elements are in a set individually and what elements maybe show up in multiple areas. With that, we always put a rectangular region around the outside of our Venn diagrams, kind of like you can see here. And this region represents the universal. So it's kind of like it's the big picture. So when we talk about this universal set here, we are talking about your big picture or the big idea. Okay. So for example, a universal set might be all the continents in the world, whereas the subset of that might be the countries in Africa. So your big picture is kind of like the big giant overarching idea. Okay, so we put this as a big rectangle because this is kind of like grabbing the overflow. U stands for the universal. And then you can see here I had 3 sets, each were different. And what we have in here is we have these intersecting points. Okay, so these intersecting points, so like this point right here, this would be an intersection of B and C. And essentially what that means is it means that this is the shared elements. Another way we like to say it is we like to say that these are the elements in common. With both sets. And so you notice we can do that for all 3. So we have an intersection here, we've got the intersection here, we've got the intersection here. Now notice we have this space right here in the center. So this space right here is the intersection of all sets. And it's the same thing. What it essentially means is it means that you have elements in common with all sets. So those elements would appear in each of these individual sets, and so they go in the middle right there. Okay, and so those are your Venn diagrams, or how we set them up. Now, when we're talking about operations with sets, we are looking for what happens when we put those sets together. So, like we were talking about, the first thing we have is we have what's called an intersection. An intersection is where we have elements that are in common to both sets. Okay. The symbol that we use is this one here. Kind of looks like an upside down N. And so, if we have this example where we have A, B, and C, and we have that A is the set 1, 2, 3, 4, 5, 6, 7. B is the set 2, 4, 6. C is the set 1, 3, 5, 7. We have these different things that we can go ahead and find. So the first direction says I want the intersection between A and B. So in other words, I'm asking you for what's in common between A and B. So here, this is going to be the set, and you have to look. In A, I have 1, 2, 3, 4, 5, 6, 7, and in B, I have 2, 4, 6. So set C here doesn't matter. So I'm looking for the numbers that are the same between A and B. And the numbers the same would be 2, 4, and 6. Now I'm looking for numbers, the next one, the intersection between B and C. So I'm looking for the numbers that are the same between B and C. So I have 2, 4, 6, 1, 3, 5, 7. Well, if you notice, there is nothing in common between those. So that brings me up to this point here. When you have a set and there are no elements in common, we call that disjoint. We label them with what's called the empty set. So this right here is the empty set. Okay, it's disjoint, there's nothing in common. Last we have the set A and C. So now we're looking at A and we're looking at C. And the intersection here would be 1, 3, 5, and 7. So one of the things that you can notice is that you can have sets with elements in common, or you can have sets with nothing in common, and it just depends on what your sets are doing. Alright, if we're not looking at an intersection, then we are looking at a union. A union is all the elements in one set, or all the elements in the other set, or all the elements in both sets. So the symbol for union kind of looks like a U for union. And so again, we can look at an example. Here I have a U to be the alphabet, A through Z. So this would be kind of like your universal. So this right here would be what I would consider your universal set. Out of that, we have 3 smaller sets, where we have M is the set bridge, B-R-I-D-G-E, N is the set gator, and K is the set ballister, B-A-L-I-S-T-E-R. The first thing I want to look at is I want to look at the union between M and K. So the union would be, again, all elements that are contained in either one set, 2 sets, or all of the sets combined. So here I just want to look at M and K, and you only write the element once. So that's a really big deal. So you are going to only write the element once. Okay? So what does that mean? Well, if I look at M and I look at K, notice they both have a B. So when I start my set, I'm only going to write the B once. I'm not going to write it twice. So the easiest thing to do is to pick one. Okay, so I usually like to pick the longer one. And you're going to start going element by element, okay, and looking to see if the smaller one has a 2. So we started with B, the next part is A. So if we look at bridge, I do not have an A, but A is contained in this one, so it counts. Then I have an L, so here's the L. I have an I have an S, T, E, R. But then when I'm looking at bridge, I have my B, I have my R, I have my I don't have a D. So I'm going to use my D. I need a G, and I have an E. So notice I'm including all of the elements from both sets. We look at this bottom one, it's a little bit more complicated. We have to always follow your order of operations, no matter what math you're doing. Well, the order of operations states parentheses first. So the first thing that I have to do here is I have to look at N intersect M. And I have to figure out what that's going to be. So when I'm looking at, I need to remember intersect means the ones that are the same. So I'm looking at N and I'm looking at M, and I'm looking at only the elements that appear in both. So here for the first, I have a B in the first one but not in the second. I have an R in the top, the M, and I have an R in the bottom, so I'm going to include the R. I have an I in the top but not the bottom. I've got a D but not in the bottom. I have a G in both top and bottom, so G. And then I have an E. Now on the bottom, the ones that I didn't state were A and O, but they don't appear. So here my intersection is just those two letters. Once we get those two letters, we can then go on to the next part, which is I'm going to take K and I'm going to union it to N intersect M, which is essentially the same thing as thinking about taking K and union it to the set RG. Now if you remember, union again says that you're going to take everything in one set and combine it to everything in the other set. So here I've got K. So again, K is going to be that ballister. And then I'm unioning it to RG. The only thing that's missing was the G. Alright, let's look at a Venn diagram problem through the idea of an application. So here I've got that the grocery store found that 275 of its customers use push carts to shop. So push carts is one topic, and 185 use a carry basket. Carry basket is the other. Notice I have two Venn diagrams. So my first Venn diagram is going to be related to the push cart, and the second is going to be related to the carry basket. Now 145 use them both. So if I want to use them both, I'm going to fall right here into my intersection. So my intersection is both, and this is 145. So I want to know how many customers use only a push cart or only a basket. So I have to figure out how to fill in this circle here. Well, I am told that there are a total of 275 customers that use push carts. So I know that this is 275. However, of that 275, 145 of them use both. So I have to subtract away the part that uses both. So I need to subtract 145. And that is going to give me how many people use push carts only. So here you get 130. I have to do the same thing with carry baskets. I know that 185 people use a carry basket. Again, I need to subtract away the amount of people that use both, because you can't count a person twice. And in this case, I'm left with 40. So in order to figure out how many people use only your push cart or your carry basket, means you have to add them together. So the number of people to use only the push cart or carry basket is going to be the number of people that use just the push cart, so this is 130, added to the number of people that use a carry basket. which is 40. So my answer here would be 170 people. So we used a Venn diagram in order to figure out the answer to my problem. Now, another aspect of sets has to do with the complement set. A complement of a set is a set of all elements from the given universal that are not contained in the original set. So you can see right here the apostrophe. So this part right here is what denotes the complement. So when you see a set labeled with the little apostrophe next to it, that means you want the complement of that set. So for example, I have this example here where I'm telling you that U for universal, okay, so that's what this is. This is the universal, is going to be X such that X is a whole number between 8 and 22. So the first thing I need to do is I need to know what my universal set is. So my universal set is going to be the set where we're a whole number between 8 and 22. So that's 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Pretty big set. Now B is going to be a whole number that is a multiple of 4. So my set B is going to be multiples of 4. So here we would have 8, 12, 16, 20. Now the question says we want to find the complement set. So to find the complement set says that I have to use all the values out of the universal that are not contained in my actual set itself. So my complement set, my B complement, is going to be the values where I'm looking at my universal, but I'm not going to use 8, 12, 16, or 20. So I'm going to use 9, 10, 11, 13, 14, 15, 17, 18, 19, 21, 22. And that would be my complement. Let's look at another example. Here I'm telling you the universal set. So again, remember that's what this is right here. This is my universal set. Is going to be all the letters in the alphabet. And then again I have N, M, and K. So you should recognize these letters. They're the same from the previous example. So the first thing I want to do is I want to find the complement of M to N. So I have the complement of M, and I'm unioning that to N. So when I'm looking at these two, the first thing that I want to look at is the letters that I have in common here. So I'm using B-R-I-D-G-E, and then I have G-A-T-O-R. So the complement of M is going to be all the letters in the alphabet that do not appear in bridge, But then I need to include that with N, so I'm looking at the set A, T, O, because those are the letters that do not appear in M. Now, in this bottom one, we're looking at the union between M and K, but I want their complement. So the first thing that I have to look at is the union between M and K. And if you remember, we did that a couple problems back. So here we're going to look at M and K. And so again, this is going to be the set where we're going to have B, A, L, I, S, T, E, R. And then we have to add on to there D and G. But then I want the complement. And since there's nothing else there, the complement I'm talking about is with the universal. So when I want M-U-K, but to complement it, I want all of the other letters except for the ones you see here. So here I am talking about C, F, H, J, K, M, N, O, P, Q, U, V, W, X, Y, Z. If we go a little deeper into your Venn diagrams, again, we're going to use the Venn diagrams to kind of organize the information we have. When we're doing that, it is always best to begin with your intersections. So what I always like to say is you want to start from the innermost part and come outwards. Okay. So before that, let's familiarize ourselves a little bit more with being able to work with your intersections and unions between your sets. So here we have A, B, and C, and I want to find A intersect B intersect C. So the first thing I need to look at is I need to look at A intersect B. So I'm looking at A and B, and I'm looking for just the values that they have in common. And so here, between these two sets, I'm going to have 2, 4, 6, and 8. Now the next thing I want to do is I want to take the set that I just found, and I want to intersect it with C. Well, when I do that, I have the set 2, 4, 6, 8. Remember, intersection is which ones are in common, and in this case, none of them. Now this bottom one here says we want to start with A union B. So to do that, A union B says we're going to put it all together. So here this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 10, and 12. And then I want to intersect that with C. So if you look at C, C is 5, 7, 9, 11, 13, 15. So when we do that, we end up with the set 5 and 7. Now notice the direction says using set builder notation. Using that essentially means squiggly lines. Okay, so remember, set builder notation is when we open with a squiggle and we close with a squiggle and we have stuff in between. Now another thing that we could do is we could look at one of these directions and we could shade a Venn diagram instead of listing things out. So here we're going to use this Venn diagram here in order to shade the solution. So we have to label them. So let's say we labeled this as A, this was B, and this is C. Obviously you can label these in whatever order you want. The idea is going to be the same. So the first thing that we want to look at is B union C. So this means all of B, which is this right here, and all of C. Okay? So that's that right there. So this first part is these two pieces, all of these. Now I want to intersect that with A. So in order to do that, what that says is that I am looking at just this part right here and this part right here. So I'm looking at B and C together, but then intersected with A, and so this is what we're looking for. Let's try another. Here I want A union C, but I want the complement. So again, let's go ahead and label. So here we've got A, we have a B, and we have a C. Okay, so let's look at this. A union C, so we're talking about all of A, and we're talking about all of C. Okay, now I want the complement of that. So that means everything except. So everything except would be everything on the outside and this piece of B here. Okay, so that's actually what we have. And when we intersect that with B, what that means is that we are looking at just this piece of the puzzle right here. Alright, last, let's go ahead and construct this with numbers. So again, go ahead and we can label. We've got A, B, and C. So when we talk about starting with the intersection, the first thing I would do is start with this absolute center. So you want to look at your sets A, B, and C, and you want to look for the value or the numbers that all of them have in common. So all of them, if you look, have this number 4. So the 4 goes in the middle. Now you want to branch out to your bigger intersections, and we want to look for, say, what number does A and B have in common with each other? So if we look, A is the numbers 1, 2, 3, 4, B is the numbers 2, 4, 6, 8, 10. So the number that they have in common with each other is 2. I can do the same thing between B and C. So again, 2, 4, 6, 8, 10. And then I have 3, 4, 6. So the number these two have in common is 6. A and C is the same thing. 1, 2, 3, 4, 3, 4, 6. So these two have a 3 in common. Once you do that, then you have to look at the numbers that are left. So here, I had 1, 2, 3, 4 was in my A bubble. The only number missing is the 1. In my B bubble, I had 2, 4, 6, 8, 10, and if you look at this, the only numbers missing are 8 and 10. In my C bubble, I had it 3, 4, and 6. I've got 3, 4, and 6, so there is nothing that goes in here. But now I've got my universals, so I need to look at what numbers out of my universal set are missing, and that's what goes on the outside. So if you look, I've used a 1, I used a 2, 3, 4, but I did not use a 5. So we have a 5 out here. I used a 6, but not the 7. I used an 8, but not the 9. I used a 10. And there you have it. So that is everything to kind of get you started with what it means to work with Venn diagrams and what it means to work with combining your sets together. So if you have any questions at all, please feel free to let me know. If you come across any other examples that you would like to see or that you need help with, please let me know those too, and I would be more than willing to work those out. Otherwise, I do hope you enjoyed yourself, and I'll see you next time.